Hi all, welcome to TechFest Java. In this video, we are basically going to discuss about Singleton design pattern. What is Singleton design pattern and how many ways we can create a Singleton design pattern. So we have in previous video of Singleton design pattern, we have been discussed that what is Singleton design pattern and how many ways to create a Singleton design pattern. So one by one, whatever the ways we have seen in my previous video theoretically, we are now looking back in this video and see one by one all the methods to create a singleton pattern practically. For that, I have been created one Java project where I have created one main class, and there is a one user class having a two fields I have been created. And now for this particular user class, I am one by one implementing all the basic steps and all the ways by which we can make it this user class as singleton. So the first way we have mentioned in that previous video tutorial is that agar initialization. So what is agar initialization? Agar initialization means whenever we already been create an object of a class, and wherever it is required, it is given by them. So for making a agar initialization, what we will do, we will just create a one private static user type of field, and where we will define at new user, and we will just provide a one public static get user method where we are just returning this user. So that's it. This is simplest way of creating a singleton design pattern, but there are many drawbacks like it is wasting the resources, because unless we are not required or not required, once it is loaded, the class is loaded, at that time this particular block of code is running and user class object is being created. Unless any other class is calling this method or not, this user object is already being created once the class is loaded. This is the first way of creating a singleton design pattern. Now the second way in the same is that when we are using a static block to create a singleton design pattern. So here what we will do, this method could be the same for that, and here what we are doing the changes, we are just defining one private static user, and we will create one static block, and there we will create a user object. So this is another way of creating a user class as singleton, and this is also loading and creating an object whenever the class is loaded, because the static block is loaded when the class is itself is loaded. So we know that when the class is loaded, static block runs only once. So this particular static block or static fields runs only once. So in both these cases, the first one and the second one, there is only one object being created. But what else if in a multi-threaded environment the class is loading? In that case, these two scenarios will fail, because suppose this class is loaded by two different threads. At that case, both the threads will load this class and create their own copy of user object. So it will break the singleton design pattern rule. And here we can make one condition that if user not equal, sorry, user equal to null, then only this particular block is initialized. So this is the second way of creating a singleton design pattern. Now third way of creating a singleton design pattern is lazy initialization. For doing that thing, we will just comment out this part, and here what we will do, we will do the modification in this method, and we will not directly use this. We just check that if this user field equal to null, then only this user block is being created, user object is being created and returns. So that is the lazy initialization, where whenever the user object is being required, a particular class called getUser method, then only if a user object is not being already being created, then only new user object being created and it will return. This third part is also fails in a multi-threaded environment, because suppose two threads simultaneously call this method one by one. So as we know that threads having their own stake of calling methods, so they will get the own copies of this method, and for both these copies the user object will always be a null. So in that case also, this is not a fully functional, or we would say fully secure singleton pattern implementation. So there is another way of creating a singleton pattern implementation, and that is called a double checking. Or the fourth one is simply we can use synchronization, either a block or method. So for that, what we have to do, we have to use a public static user get user. We can make this method as get user with lazy loading, we can say, and here we can say get user with synchronization. So here you can just use a synchronized block, and we will pass this user. And in this we check that if user equal to null, then only we can create a new object of user and it will return user. In that case also there is a problem. In a concurrent thread scenario, if the two concurrent thread can access, we know that thread execution can be within a nanosecond. So there is a possibility that one thread is executing over here and another thread is doing the checking the condition over here within a nanoseconds. So whenever this particular thread getting initialized, until and unless this particular line being executed by another thread, like I would say that T1 is running at 0.00 0.001 nanosecond, and here, or I would say 1 nanosecond. Here at the same time thread T2 checking condition. So before it get executed by T1, T2 is also already checked that particular condition and found that user itself is null. So in that case T1 and T2 both the threads can be execute this line and create a user object twice by two threads. So to avoid such condition, there is a concept called double checking. So this is the fifth way of doing the implementation of a singleton design pattern, that is called double checking. What we will do, we will take a same example over here, but we will check before the synchronized block also. The null condition we can check before the synchronized block also. And if these conditions being passed, then only this user object will return. So if user equal to null, then suppose that particular thread will goes and this particular thread got the lock on this. At the same time this particular thread will not work. So by double checking we can easily make our class as thread safe synchronized way, and singleton design pattern is also persist in that. But there is a possibility that this particular pattern is also break with this method by in the class is loading in two different class by the two different class loaders. At that time there is a in multi-thread environment also it is breaking. So there is a one more way of doing the singleton implementation of singleton pattern, that is enum. So what we can do, we can simply define one enum, and here with the enum class itself we are returning an object. So in place of we are defining this class, this user as a class type, we can define this as a enum type and returning an object from there. Simple. So this is called the simplest and safest way of implementing Singleton design pattern. So these are the ways by which we can implement the Singleton design pattern. In next video we will see that how many ways we can break this Singleton design pattern. So in previous videos we have been discussed about theoretically that there are the 4 ways we can break that Singleton design pattern, and now we will check one by one all these Singleton design pattern and the way we can break these Singleton design pattern, and what would be the why enum is called the safest and simplest way of implementing a Singleton design pattern. So in the next video we will discuss all these scenarios. Thank you for watching. If you